Okay, I'm going to take a minute to talk about the vocabulary of polynomials. We're mostly obviously focusing on quadratics, but they're not the only kind in the world, so. Okay, so basically a polynomial is something with one term or multiple terms, any finite number of terms, and each of those terms is a number times a non-negative integer power of a variable. So it doesn't have to be x, it doesn't have to be y or a or anything, but you do have to have that the numbers are all real, that are times the variables, and then the variables have to be an integer power. So if you don't write it, so like that is a polynomial if you want, because there's this kind of imaginary x to the 0, and 0 is a non-negative integer. 3x is a polynomial because there's an imaginary little 1, and that's a non-negative power. This is a monomial, this is a monomial because they have one term. So you can have monomials, you can have binomials, which can be like this, or negative 8x to the 50 plus 2x. That's still a binomial. A trinomial has 3. That's why before we were saying perfect square trinomial. And normally we don't name them after that as far as how many terms they have. But so these are each called terms. So each individual piece, ax to the n, where n is equal to 0, 1, 2, 3, and so forth, and a is real, each of these is a term. And if I grab up several of these that are finite and list them all in a row, then it's a polynomial. And I don't have to put them in order. I can say 5x to the 7 minus 8x to the 12 plus 3x squared minus x to a million. It doesn't matter what order they're in, as long as there are finitely many, and each of these powers is an integer and not negative. So, for example, if I write 3x squared minus 7x plus 5 over x, this is not a polynomial. The rules of exponents say that if I write this as an exponent of x, it's x to the minus 1. So even if I'd written it this way, it kind of looks like a polynomial at first, but since this is negative, it's not. And if it was, say, 3x squared minus 7 root x plus 5x, this one is also not a polynomial because first I'd have to write it as powers, and that's to the 1/2 because there's an imaginary 1 there and an imaginary 2 there. And this is not an integer. And by the way, if it's like the cube root of x, there's still an imaginary 1, but now it's a 3. If it was the cube root of x squared, x to the 2/3 and so forth. This one out here is always on the bottom and this one's the top. If that's not written, it's 2. If that's not written, it's 1. So this is also not a polynomial. If I had this one, the first thing I need to do is write this as powers. And even though this was written in a way that made me feel like it wasn't a polynomial, 4 over 2 is an integer. That's 2. So this actually could have been written 3x squared minus 7x squared plus 5x, which would be negative 4x squared plus 5x. And in standard form, polynomials always do have descending powers. Okay, so the next thing is what the number of terms, you just count out the pieces. So if I have 5x to the 75 minus 8x to the 12 plus 3x squared plus 2, the numbers are called coefficients. So the coefficients are 5, negative 8, 3, and 2. The number of terms is just 1, 2, 3, 4. You just count them, 4. The degree of the polynomial is the highest power of x, in this case 75. If I had written this as 3x squared minus 8x to the 12 plus 5x to the 75 plus 2, almost certainly, depends on what you're doing, but almost certainly you want to rewrite it in order. So then my first step would have been this, but no matter which one of these, 75 is still the degree. And the leading term is always the term of highest degree. So even if it's written in this order here, 3x squared minus 8x to the 12 plus 5x to the 75 plus 2, it feels like now this is a leading term, but it's not. It's the guy in front, but it's not leading because it's not the biggest power. So 5x to the 75 is the leading term. The leading coefficient is the number next to the highest power of x. So it's the number part of the leading term. And the constant coefficient is, in this case, 2. If I didn't have a constant term, I would just say 0. Okay, so this is sort of vocabulary and definition of polynomial, so that now we can look at these. Okay, so polynomial with degree 2, so the highest power is 2, is called a quadratic. And a quadratic can be always factored into either linear terms with real parts or linear terms with complex parts. But it's either both real, and they may be the same, so that you only have one, or both complex. You don't have one real and one complex. So when you factor them, one way, which really mostly works if you have leading term 1, because once I'm trying to factor it into something like this. These are linear terms, and if the leading coefficient is 1 on your quadratic, then these are both going to be 1. So when we do this, foiling, we would end up with x squared plus bx plus ax plus ab. So this is x squared plus b plus a times x plus a times b. So if it looks like this, we need two numbers that when you add them together, live there, equal this number next to x. When you multiply them together, they make the last term. So this one, I believe we were looking at I think it was p squared minus 4p minus 5. So we want two numbers that multiply together to give negative 5 and add together to give negative 4. So I come over here, negative 5 only factors two ways, 1 and negative 5 and negative 1 and 5. So if I add these together, I get negative 4, and if I add these together, I get positive 4. I want negative 4. So these are my values. Because of this 1, we can just write plus 1 minus 5 and its factor. And that's it. Okay, so now 2n squared plus 36n minus 38. 2, 36, negative 38. I don't remember if this was x or what, but I'll write x for the moment. Okay, so, oh, you know what? I think it was n. The first thing is we just practice factoring out common terms. Whenever you're trying to factor something, you immediately factor out common terms. Always, always, always. You want to make it as simple as possible before you start trying to deal with anything slightly more complicated. So there's a 2 everywhere, so the first thing is to take out a 2. So we take 2n squared divided by 2, 36n divided by 2, 38 divided by 2, and we have this. Now I want to factor the negative 19, and it's prime, so there aren't very many ways to do that. And if I add these, I get negative 18, and if I add these, I get positive 18. I want a positive 18, so I choose these two. So 2 times n minus 1, n plus 19. Oh, that's backwards. W squared plus 20w plus 19. Okay, so for this one, there's nothing to factor out to start with. So that's the only ways to factor that. So that adds to 20, that adds to negative 20. I want positive 20. Five, 40, negative 45. Okay, so this does have something to factor out. If I factor these, when you have a quadratic, unless it's been written crazy, if you have all 3 terms, you can't get any x's out because this one isn't going to have one. So you're only looking at the numbers generally, but I could have a y here, a y there, a y there, and then I'd factor that out too. So as it happens, I've got 5. I've got 5, so let me do this. 5, nothing to be done with that. 40, 5 times 8, which is 2 times 4, which is 2 times 2. 5 times 9, which is 3 times 3. So the common term is 5. 5x squared divided by 5 is x squared. 40x divided by 5 is 8x. Negative 45 divided by 5 is 9. So 1, negative 9, negative 1, 9. 3, negative 3, negative 3, 3. Well, that's the same. So this makes negative 8, this makes positive 8, this makes 0. So the one I want is the positive 8. And honestly, it might behoove you to stop the video and, practice and see where you are in it. And then if there's something that keeps going wrong, when you come back to the video, you know what to look for. This is 1, so there's nothing to factor out, because I would never be able to factor out the k's, remember? Old habits. Okay, I'm going to do, I guess, one more. 8, 40, 32. Like this. Oh, these were Q's, weren't they? Okay, so 8 is 2 times 2 times 2. 2 times 2 times 2 times 5. 2 times 2 times 2 times 2. So each of these has 3 2's. The other thing is, remember that if one of the numbers goes into the others, then that is the common factor. In this case, 8 goes into 40 and 32. So we could have known right away. 8q squared divided by 8 is q squared. 40q divided by 8 is 5q. 32 divided by 8 is 4. So we have 1 and 4, negative 1 and negative 4, 2 and 2, negative 2 and negative 2. Those add to 5, negative 5, 4, negative 4. Okay, so I think that that's enough of this one. Let me see. Okay, I think I'll do a few of these. I'm feeling honestly a little bit like I need a break, but I'm going to do a few of these, and hopefully we can make sense out of this one, and then I'll come back and make a separate video about solving, and then maybe a separate one about the quadratic equation. Okay, so 3, 8, 5. Oops. Did things out of order there. I forget what this was. I'm just going to make it x. Okay. So when this is not 1, then that means one of these terms didn't just start with x. Because if this just starts with x, in both cases, you get x squared. So in this case, one of them had to start with a 3. But this could be a 12, and then you wouldn't know if one of them started with a 3, and one with a 4, one with a 2, one with a 6, you know, like that. You don't know. So the way that I normally approach these is by grouping. And hopefully you have used grouping before. We talked about it kind of without saying what we were talking about. I find myself a good spot here. Okay, so grouping is basically undistributing. So if I had, say, 3x cubed plus 4x squared minus 3x minus 4. Because it has 4 terms, and you'll learn this later when you do Beyond Quadratics, one of the things you want to try if you have 4 terms is grouping them into 2 pieces. So the first piece would be 3x cubed plus 4x squared. And then the next piece, because of that minus, I'd go ahead and take the minus out and do 3x plus 4. That's taking the minus out of both of these. I should have made this not end up 1, but okay, so there's an imaginary, what I'm factoring out, let's say, is minus 1. So then you take this one and factor out the common terms. So the common term is x squared. 3 and 4 don't have anything in common, so it's just x squared. And then 3x cubed divided by x squared is 3x. 4x squared divided by x squared is 4. And then once you have this, because you have 3x plus 4 here and 3x plus 4 here, that's actually now a common term. So you can just call it blob if you want to and say I have x squared blob minus 1 times blob. And so that means if I take the blob out, I've got x squared times blob divided by blob minus 1 times blob divided by blob. And then, of course, this one's a difference of squares. And so if I wanted to factor completely, I'd go ahead and factor that bit. Okay? So 385. I'm going to start a new page here. Yeah. Okay, so before, when we were factoring this last number, we were really truly factoring the last number times the first number. It's just that the first number was 1, okay? So now we have to take these two together, and they make 15. I need to factor 15. Because when I FOIL, I would have gotten a times c, x squared, plus a dx plus b cx plus bd. So the AC part shows up in here, but not over here. I don't know if that really makes sense, but when we're trying to unfoil, we have to take this number times this one to get these both, to get the middle part, not just this part. So we have to find the A and the C. So 15, we've got 1 and 15. Normally, we would do 115, -1, -15, so on and so forth. But let's face it, that if we're going to add 2 negatives, we're not going to get positive 8. So because this is positive, I'm going to skip the negatives. So I only have these two. So 16, 8. So I need the 3 and the 5. So what we're going to do is we're going to group instead of what we did before, because I can't just write x plus 3, x plus 5. Then I'll end up with a 15 over here, right? So that's no good. I need the 15 to be split with the 3 and the 5. So I'm going to write 3x squared plus 3x plus 5x plus 5. So I'm replacing the 8x with 3x plus 5x. That's all I'm doing right now. And then I'm going to take these two pieces and these two pieces. I can factor 3x out of here. And 3x squared over 3x is x. 3x divided by 3x is 1. These two terms have a 5 in common. So I've got 5x divided by 5 is x. 5 divided by 5 is 1. And then these match. So this is now my common term. So I'm going to factor out blob. 3x times blob divided by blob is 3x. 5 times blob divided by blob is 5. And now it's factored. Oh, I waited too long and got it confused. Okay, so 299. So I need to take these two, 18. And again, because this is plus, I'm just going to use positive ones. So 1 and 18, 2 and 9, 3 and 6, and that's it. 19, 11, 9. I want 9. So 2x squared plus 3x plus 6x. So that's replacing plus 9. Out of these two, I can only factor out x. Out of these two, I can factor out 3. Now I'm going to factor out this. X times blob divided by blob. 3 times blob divided by blob. Three, 10, 3. I think I'll do 3 more of these maybe. And then take a break and then do the rest. Those make 9. This is positive. If this was negative, I only list negatives. If this was positive, I only list positives. If this is negative, if this was negative 9, I'd list them in every possible combination. But if this is positive, then I just choose the ones that match this. I want 10. So 3m squared plus, placing that 10 with a 1 and a 9. And now grouping these. So out of these I can take an m. And out of these I can take a 3. And now I factor out this. So blob. M times blob divided by blob. 3 times blob divided by blob. Two, 9, 10. Oops. Huh. Sorry, that was crazy. Okay, so we'll take out 2 because of the 2 and the 4. And x, 2x squared divided by 2x is x. 4x divided by 2x is 2. I can only take out a 5 here. 5x divided by 5 is x. 10 divided by 5 is 2. 2x times blob divided by blob is 2x. 5 times blob divided by blob is 5. I wonder if it's ever going to give me one that's a minus for this coefficient here. I'm going to do a couple real quick without doing the work to see if I can get it to give me one that's negative. So let's see. 22, 11, 2. So far not good. 7 and 2, so 2. Well, this is a little more interesting because at least we have a negative number, so 2, 9, negative 11. That was weird. Okay, so these two make negative 22. So I've got 1 and negative 22, negative 1 and 22, 2 and negative 11, negative 2 and 11. So negative 21, positive 21, negative 9, positive 9. I want positive 9. Replacing the 9 with 11t minus 2t. And out of these two, all I can factor out is t. Out of these two, I can factor out a negative 1 only. Okay, so 2t plus 11. T times blob minus blob is t. Minus 1 times blob divided by blob is minus 1. Okay, so hopefully this has been enough for this. And I think I've already linked to this one. So I will start uploading this video and then we'll come back to solving a quadratic. And then we'll come back with quadratic equation. Hopefully I can get this all done today.